last call for homework. That's it. Let's get started. We have another in-class today, so I'm going to pass back last week's in-class that I graded while you're doing today's in-class. So let's get started on where we at. Today is September 10th, where you just hand in the homework while it's fresh in your mind. Let's go over it. Okay, I like to mix it up so you don't get bored. So I'm going off the syllabus and getting to chapter 10 so we can be ready for our in-class assignment at 5, whatever time I set the alarm at. If we got time, I'm going to go back then because I didn't do the grading scale yet. Missy, I did everything but the grading scale I still have to do, and there's another thing I want to talk about if we have time, or I'll talk about it on Wednesday. Okay, there's 4 inventory models you're going to learn in this chapter, chapter 10. Chapter 10, I kind of find it being slightly the second or third easiest chapter, so I'd like to keep, that's why I have them up front. This chapter stands on its own. It's not, you didn't have to have building blocks to get to this chapter. Chapter 10 is a job all on its own. By the way, smaller company, the job of managing inventory and controlling inventory is probably somebody who wears a lot of hats, because it's a small company. And they're probably just doing the best they can. It's a small company. I was at a small company once, and part of inventory is my responsibility, as well as all the financials, as well as, you know, there's accounts receivable, accounts payable, human resources. And if you're at a small company, you wear a lot of hats. But at a bigger company, the bigger it gets, the highly more significant the probability is that you're using fundamental management, mathematical analysis type of techniques to make decisions instead of just winging it the way they were trained. The bigger they are. And the bigger the company is, a job could be inventory management all on its own. So when I start going over these and you say, wow, I'm not a math person, but I love these because it makes sense, you know, look for, just start going on any of those job switches and put inventory manager or inventory control or anything related to warehouse or inventory, and you'll see all kinds of great paying jobs related to just doing this. Now the reason this chapter is so important to me is because when I was working for the consulting firm, I would go to all these different businesses. And the smaller the business, meaning the amount they did in sales, like if there were 20 million in sales, let's say 10 million in sales a year or less, they're probably not doing this at all. The odds are huge that they're not doing this. And this is usually where I would start my week. I spend a week with the company analyzing it, and I would start with their financials, but then I'd start honing in on their inventory control, because this is almost always one spot where they could save money and stop wasting money and increase profit. Usually when I was there, they're at a point where either they're already losing money or they're about to lose money, and they need to pinpoint what they need to do to get back, get back to profit. Inventory management is a big one. So when I start analyzing the company, I go out to the warehouse, and I'll start going, okay, hey, look at this. Wow, how many different items do you have here? I call them SKUs. Anybody ever heard of SKUs? Okay, SKU is a number assigned to every item at every company. And a company who has a warehouse that's doing 10, 20, 30 million sales, they probably have thousands of SKUs that they have. Some are out on the floor if they happen to sell retail, some are in back, and both, depending. But all of them, as a company gets bigger, they realize how important it is to not have money wrapped up in inventory that you could be freeing up somehow and using to expand your business and create more sales. They go into different directions. As the world changes, your company has to keep changing. Or you'll start to see your sales drop, and you'll start to go, whoa, what's going on here? You're not keeping up with what people want and what they need. So you always got to change as the world changes, as the market changes. So now, with inventory control, you have all these different items. So when I go to a warehouse, I would say to the person, okay, what's the process of restocking this item if you run out? I used to work for a bathroom manufacturer. Anything in the bathroom you think of, I worked at this company that made it. They made these things. I was down in Mansfield, Ohio to start with. Anybody heard of Mansfield? There's a company, matter of fact, called Mansfield, toilets and stuff. We were a competitor in the same town. We had China plants, meaning ceramic. We made ceramic items, like only down the road from another company making the same stuff. Toilets, tub surrounds, new tubs. faucets, vanities. And I point at the toilets and I say, now what's the process? And the inventory person who's helping me write that would say, okay, when that starts to get to a certain point, I fill out this tab because I know it needs to be reordered. And then I put it in this envelope and I address it to accounting. So I say, okay, thanks. And I say, do one for me. So is there anything here that needs to be ordered? And then I watch them do it and I kind of time it. Let's do another, try to get an average. Then I take it and go, hey, where's accounting? I'll go to accounting, I'll take that tag, and I'll say, hey, so-and-so needs an order, who does this go to? And I'll go to that person who places orders. And they'll go through exactly how they put an order together. Now the reason I'm telling you about all this process I used to do, you're reading all that at home, right? Is because to find out how many should be ordered, this is what should be calculated. Now I'm just introducing you to inventory management. And this formula especially, is if a company has sales that are pretty constant, just little fluctuations through the year. Most companies do not have steady sales. They have cycles. When you get into operations management, you're going to go a step farther with each of these to where it takes cycles into consideration and there's all these other calculations. You're going to get more depth. I just want to introduce you to it so that you're not only prepared for operations management, but I just want to see if hopefully get someone excited about inventory management and think about it as a career because, this is your thing. This is not a bad career. It pays well, especially if you save the company money. It pays really well. So what the deal is, this formula, I'm going to identify each letter, and this is where you got to write something down in your notes, especially on D. In order to figure out, we order these from our supplier, the warehouse, the company does. And I say, well then, how do you determine how many to order from the supplier? And the answer I almost always get is, well, we always order 50 from that supplier because that's just how we've always done it, and that's how I was trained. So it's the number one answer in everything that every question I ask on why you do this or why you do that, it's always, this is how I was trained. It's almost always. No one ever said, oh, by the way, you can save money if you do this a little differently. They just go ahead and say, this is how I was trained, so this must be the right way to do it. So the formula is how many you should be ordering instead of, what I say, 500 or 50 or whatever, is square root of 2. No other number but 2. It's a constant. It's there. 2 times D. In this formula, D represents demand. How many of that item do they sell in a year? I want you to underline the word per year. Hey, we sell 10 toilets a month on average. 10 per month. What's going to be the D in this formula? 120. Convert it, 10 per month, 12 months in a year, that's 120 annual demand. We sell 20 of these about every quarter of a year. How many do what's D? 80. 20, there's 4 quarters a year. Get it? However demand's presented to you in any of these problems, you've got to convert it to an annual. If it's not already being given to you as annual. I think the first problem today is probably being given to you in annual, but don't expect it that way. Read it carefully. C sub O, C with the little O, stands for the ordering cost. Remember when I said I go to the accounting department, I start asking him or her, how do you place an order? Well, I go into our accounts payables to see how many I ordered last time, to see what we paid. I see what other items we order from this particular supplier, and then I see where those are to see if maybe I could add to this order, on and on and on. Meanwhile, I'm trying to figure out all the things that are involved in putting an order together. Then I go to payroll, and I look up what the person in the warehouse and how much time they spent putting their part of the order together, and I multiply times what their pay is. I'll go to accounting, I'll look up that person's pay, and I'll start going, okay, on average they spend 20 minutes or a half hour on putting an order together. I'll look at their pay. What supplies did they use? What's involved? You gotta remember, I did this almost 30 years ago, and back then they would get on the phone to place the order. I mean, now they go to a web page, every supplier has that, and they put the order. But they get on the phone, and I would watch. Can you place this order while I'm here? Yeah. They'd small talk for at least 5 minutes. So you got to add that to every order. And so that's how you come up with that ordering cost. Anything involved in getting an order placed has a cost. And if that time wasn't spent doing that, that time would be spent hopefully doing something else productive. And in this class, I'll always give you that ordering cost in the story.
for the problem. You'll be given it. You don't have to convert it and just say every time an order is placed it costs $80, $20, $30, whatever. That's your C sub O. Time does not matter. It's how much it costs to place one order. Divided by C sub H. That stands for holding cost. Holding cost sometimes has a calculation involved, sometimes doesn't. For example, if I said, and the holding cost for this particular item is 3 cents. I'm going to do that, 3 cents. Well, then the holding cost up there would be 0.03. Or it may say it's 10% of each item is spent on holding. What is the cost of that item? In the story, it will say the item is $60 that we buy from the supplier. What's the holding cost per item then? $6. You'd put the number 6 for C sub H. You get it? If it's a percentage, you've got to also read the story to find out what the cost is for one item, multiply them to get the holding cost. If the holding cost is given to you as a number, let's say it says holding cost is $1. You then just put the number in there. You don't have to do any calculation. It wasn't given to you as a percentage. Most of them are given to you as a percentage, and you will have to then look up the cost and multiply them to get that holding cost. Don't figure out a whole year, nothing like that, just the percent times the cost of one item. Then you plug it in, you calculate, and all of a sudden you go, wow, you shouldn't be ordering 50 every time you place an order. Every time you place an order, you should be ordering that. And what happens is, you need to know this part also. We're doing total cost on every one of these. Total cost has, in this particular formula, called EOQ, has two parts. The overall holding cost for a year, the overall ordering cost for a year. The formula is always 1/2, 0.5, divided by 2. Whatever this is, it's stated different ways, PowerPoint, internet. 0.5, 1/2, divided by 2, all mean the same thing. Times the optimal quantity that you just calculated. Times the holding cost. That's the same number you used up there. $1, $6, 3 cents, whatever. There's the holding cost. Here is the ordering cost. The annual demand times the cost for one order divided by the quantity ordered each time an order is placed. There's the ordering cost. If a company is ordering too few items, lower than what they should be ordering, they're going to be placing more orders during the year. They'll have lower holding costs, but their ordering costs will be much higher. A company who orders too many at a time, they got them sitting in the warehouse too long. That means that's the worst scenario. That's money tied up that could be doing something else to help you make money. And this holding cost side here is skyrocketed compared to the ordering cost. In order for a company to stop wasting money, they have to figure out at what point is our holding cost and ordering cost the same? How many do I have to order from the supplier to get those to be the same? Because once I get them the same, that's the least I can get my yearly cost on buying from this supplier when it comes to ordering and holding, warehouse and placing orders. And that's the only way. If one of these are out of line, you're wasting money. Money's going out the window, wasting. Now, here's what I always did when at the end of the week, I had to put a presentation together, say, here's your problems, here's what I'm recommending if you want to start getting back to profit. And if inventory is the problem, here's how I demonstrated this. I'd always say, when I talked about this toilet that's being warehoused, as an example, I was told you order 500 every time. But you really should only be ordering 222. To make my point, I'd say, let's make Q what you order now. What did I say, 500? 500. And let's calculate total cost. Now, if you change the way you order with your supplier on that item to 222, now recalculate. No other number changes, just the amount they're ordering. And always, I love to start my presentation with this because their jaw would drop every time. Because they'll go, oh my God, that's $2,000 a year more in profit by just changing the way I order from the supplier on that item. Instead of ordering 500 every time, order 222. Yes. And then their jaw drops because you can see the light turn on. And they turn to me and they go, I have thousands of items out there. You mean this is possible with every one of them? And I go, yes. And that's it. And then all the other things, of course, there's other problems, but that one is almost always the case for a small business. Because usually, whoever's running the business, because it is smaller, has never learned this. And there's a lot of times I was brought in to where a family owns a business because the true entrepreneur or the person who started the business died unexpectedly. And they're running this $10 million business and never studied business, ever. And they're actually learning it from those who were running the company with their father or mother who died. And they're learning the business themselves. And this is usually, that's a typical situation where tons of money is being wasted because of poor inventory management. Quick example, you ready? This barometer company sells barometers. And in the story it says they want to do an inventory policy. They have not had fundamental math involved in deciding how many to order from the supplier. They're a retailer. They sell all these different weather equipment out in the store, but they have stuff in the warehouse. And the barometer that they get from their supplier that they sell costs $50 each. That's how much it costs. They sell how many? The retailer exclusively inventory. They sell 500 per year of those barometers. Do you have to convert that for demand? No, it's already in. And let's see, what else we need? We got our D, but this is not involved in figuring out the optimal quantity. Why would we be given the cost per item? Well, there must be more to the story. And sure enough, it says your holding cost is 20% of the cost of the item. How much is our holding cost in that calculation then? Say it again, I heard it. $10. 20% of $50. So it says 20% holding cost. In the other paragraph, it said each item costs $50. If that's the case, the holding cost is not being given to you as a number. You've got to calculate that holding cost. So we're going to use the number 10 for C sub H. Every time an order is placed, it costs $80 to place an order. There's our C sub O. So we've got square root of 2 times, I forgot already, how many we sell? 500? How many we sell? 500 a year, times our ordering cost, which is $80, divided by our holding cost, I think you said $10, is that correct? $10, we square root the whole thing. This is where I bring up order of operations. Some of you may not have had algebra or math in a long time. So, the other class gave me a hint. It was my mother. Anybody know that thing? Because I need it. Please excuse my dear Aunt Sally. First time I ever heard that last week. P means do parentheses and exponents first when you see a math problem. Do multiplication and division next from left to right. Do addition and subtraction next from left to right. So in this case, I'm going to do all of this multiplication and then divide from left to right here. I don't see any addition or subtraction. I don't see any exponents. But my square root's around the whole thing, so I got to wait to do that. 2 times 500 is 1,000. 1,000 times 80 is 80,000. Divided by 10, and then I square root the whole thing. 80,000 divided by 10 is 8,000. Square root of 8,000. Let's get here. Right here is 89.44. Round up. Hey, you should be ordering 90 barometers every time you place an order from that supplier. 90 of them. But forget the rest of that for a minute. Let's get the total cost for a second. You ready? We now know that Q is 90. I'm going to write this down. This equals, I'm rounding, 90. All right. Next, total cost. 1/2 times, what number goes right there? 90, because they should be ordering 90 every time. Times, what number goes in holding cost? I heard it. $10, 20% of 50. Same numbers used up there. Annual demand, how many do they sell? 500. Or every time they place an order, how much? $80 divided by how many do they order? Or should be ordering? 90. When you calculate this, because we rounded from 89.44 to 90, the holding in ordering costs will be slightly off from each other, but they're going to be as close as you can get to being exact, because that's how you keep your costs down. Sure enough, let's get the total. We have total cost right there. There's the formula, 20, what is this? 90 divided by 2, what's the point? Your holding cost, 20 cent holding cost. What's going on? Oh,
Darn it.
already did the math on this. That's what they did.
Where's that at? Already applied algebra. Here we go.
Q divided by 2, 20% of $50 for each barometer. That's what's going on. 20% for each barometer, $80 every order, 500 is how many we go through a year. Plug in Q now. We're plugging in a 90 here, plug in a 90 here, do the math. They told me they order a 50 each time. I'm going to pull a 50 here and a 50 there, do the math so they can see how much they'll save by ordering 90 instead of 50 from that supplier. Do algebra. So this comes out to here, divide by 2, that's a 5, all you have left. 80 times 500, there's 40,000. Just plug in the Q now. And sure enough, where is my total cost? 90 and 90. Look how close they are because we rounded. Just those barometers are now all going to cost you for holding and ordering $894 a year. And then they have thousands of different items that they can apply this to. Everybody get this? Hang on, there's another part I want to show you. Total annual cost, optimal order, how many orders a year? All right, how many orders do they make a year? Number of reorder times per year. Well, they go through 500 of them in a year, and if we're going to change our ordering to 90 per order instead of however many we usually order, we're going to be 500 divided by 90 every time we order. We're going to be ordering about 5 to 6 times a year. Either ordering our 5th one right at the end of the year, or maybe our 6th one right then the next year. About 5.5 times a year we'll be ordering. The other thing, so you need to know for this one, your optimal ordering quantity, your total cost, number of orders per year, and the last one for this one, before we get to production, is lead time, or no, reorder point. Reorder point. Okay? Reorder point is so important. You want to take a pause. Inventory management, this is where you earn your money, is that you're constantly making sure the reorder points are correct on the inventory system. Anybody ever worked at an auto supply store or AutoZone type place? They have tons of SKUs, right? Tons of them. But they have an automated inventory system, and every time someone walks up and buys, hey, I want some brake pads, it gets scanned at the cash register, the customer walks out with it, you go check inventory, you'll see the number just got reduced by 1 for that SKU or that particular inventory item. Don't forget, when I say inventory, I mean all the stuff on the floor is part of the inventory, not just in the back. I know you guys got some racks back there, I don't even know if you have a warehouse store.
Usually not.
Yeah, it's just racks, right? And most of the stuff's on the floor really, right? So, but that's part of inventory, is the stuff on the floor. What happens is once that computer who's constantly monitoring your inventory count, the count of those brake pads get to the reorder point, at the end of the day, a manager always runs an order list, meaning what things have hit the reorder point or below. And that list has every item that needs to be reordered, and if you're running a true, called just-in-time inventory system, you want to make sure to make that order the very next day or you're going to run out. Because just-in-time inventory system is the way you have the least amount of money wrapped up in inventory. And the philosophy is, the moment the last item is being sold and heading out the door, there's those brake pads, and it's the last one we have to stock. If a good inventory manager placed the order at the right time and had the right reorder point, the new shipment of brake pads are arriving on the dock, right as the other ones go into the last customer, in order to never lose a sale. And that's mostly the objective of many companies, is we don't want to lose a sale. Especially many of them have a competitor right down the road. The only time you don't want to worry about losing a sale is when there's no competitor and you know that customer is going to come back when you finally do get it in. And in that case, we're going to learn an inventory system where you purposely do want to run out because you know the customer will come back. And there's huge advantages to, hey, it's going to be a couple days. You're running out for a few days. Because that's less money than wrapped up that you could be free enough to expand your business in a different direction. And that's one you're going to learn Wednesday. All right, so for this, can you do the number of orders per year? Can you do the total annual cost? Can you figure out the optimal quantity?
And all you have left is the reorder point. You ready? The reorder point should always be however many will be sold during the time you're waiting for your order to arrive. That time, let me say that again. I see everybody writing this down. The reorder point is however many would be sold during the time that you're waiting for your next order to arrive. So by the way, the time from when you place an order to the time the order arrives is called lead time. And your reorder point is all about that lead time. So with barometers, we're going back to the story. When we order these barometers, we order them from overseas. And it takes 10 working days, 10 days, to get those barometers in. So you have to say, as an inventory manager, when I get to that point on barometers that I only have 10 days and I'm going to get new barometers in, I want that inventory level to be however many barometers I almost always sell in 10 days. But I don't know how many I sell in 10 days. I know I sell 500 a year. I can calculate my average for 10 days. Because I'm open how many days? A year. 300. It says 6 days a week, close 2 weeks in August, open 300 days a year. I go through how many in a year? 500. Divided by 300 days will tell me how many I usually sell each day. Then the lead time is 10 days. However many I sell each day, multiply times 10. My reorder point is that many. The amount I would most likely go through in 10 days. Now, in real business, your reorder points get adjusted a little. Up a little, down a little, based on, I think things are changing here. And a good inventory manager recalculates that lead time amount probably every few months because things change. But it's all on software now, so it makes it real easy. But I want you to see how it's done so you understand what these numbers mean. Excuse me. All right. I spilled my water over here. Here's my empty cup. I put it here, there was no water, and I followed my trail, and there was no water the whole way I walked. I don't even know where I spilled it. A whole glass of water somewhere along the way. I bet it's where I plugged in this fan. All right. You ready? How many do we go through each day on this calculation? What's 500 divided by 300? 1 point what? 6.7. So I'm just going to say 1.7 to make it easy. How many will we go through in 10 days? 17, because it's on your reorder point. The average amount you go through during the time it takes to get an order in from when you place it, which is called lead time. You'll always be given lead time. You'll be given how many days the company's open, so you can figure out what your daily or monthly sales are, so you can compare it to the lead time and figure out the reorder point. That's it for EOQ. Those are the subjects you'll be quizzed on. Any questions? We'll go to the next one. All right. So, everybody got the subjects. Reorder point, there's a lot of other subjects out here. This is all we're covering. You'll cover the other ones plus some more in operation. Next. There we go. Economic production lot size. Look at this formula. It's very similar. Very similar. Now, this is an open book, open note, quiz and final exam. So when you are reading a problem and it's asking about inventory, you're going to go, okay, chapter 10. You're going to learn 4 inventory models in chapter 10. Where you don't want to waste time is when you're reading a problem, recognizing which model is being described there, so you use the right formula. The points are placing the correct numbers in this formula. That's where most of the points are. It's not this calculation of your answer right along. That is worth a little bit of points too, but most of the points are that you recognize what your holding cost is, which formula you use of the 4 inventory systems, and that you interpreted the problem correctly. Now, the way to recognize a production lot size problem is the only one that's all about how many should we make, manufacture, instead of buying from a supplier. It's how many should we make. A run, a lot size, which is how many you do in a run. Let me make sure you understand a run. Whenever I talk about this, a company down in Detroit that used to make fishing lures and all kinds of fishing equipment. They manufactured it right there. Their big deal was they spent like $1 million on this machine. And this machine could do all kinds of different things. But they could only make one thing at a time. And so they have to decide how many of this particular item do we make before we shut the machine down, retool it, change everything, and then run another lot of something else. That run, or the lot, is how many should be made before you shut the machine down, retool it, and make something else. And every time you shut the machine down to retool it to make something, or shut it down again to retool it to go back to make the item you're talking about, it costs money. That's called a setup cost. I was in a GM family when I grew up. Has anybody else had parents or anybody in general? Okay, if you remember July, your parents or whoever, brother, sister, were always home because they did what's called changeover in July. They retooled all the machines to make the next model year of cars. And there's a huge cost in their setup cost. Even though it's only once a year, it's huge. Because it takes them 2 weeks of the most expensive employees in the shop, the skilled labor, to set that all up. Well, that setup is now the C sub O in this problem. It's no longer an order. You're not ordering from a supplier. It's how much does it cost to set this up to make the item, called the setup cost. So there's your C sub O on this one. Same letter, different definition. Demand is how many of that item you need to make in a whole year. How many of these do you sell, and however many times you're going to make them, and however many you're going to make, got to add up to the amount you sell in a whole year. So that's your annual demand, how many you sell. The setup cost, how many you sell, the 2 is constant, just like every one of these formulas. All right, here, this was a little different. 1 minus, this is going to be in proportion. It's always, this little division here is less than 1. Because your demand is always less than your production capacity. Let me make sure you got that. P, here's this machine. We're trying to figure out how many we should make before we shut it down to make something else. P is if we kept that machine running the whole time our business is open, making that one item only, what's the most we could make, called capacity. Production capacity. We had that machine running during the hours we're open, making one item all the time. What's that capacity? But your demand is always either equal or less than capacity because you can't make more than capacity because you never sell more than capacity. So this D divided by P will always be a number less than 1. Let's say it's 0.55. Then subtract it from 1. So now it's 0.45. It's the opposite of what you just calculated. Get it? Then multiply it times your holding cost. C sub H is the same as it is in the other formula. How much does it cost to have an item in inventory? Whether you bought it from a supplier or you made it yourself, you're still putting it in inventory, waiting for it to go out the door to a customer. So C sub H, holding cost is the same. Okay, I'm going to read the story. How are we doing in time? I'm going to start reading the story, and we're going to plug the numbers in. Hey, this company, this tile company, they make 100,000 tiles on this machine every time they do a run. They do it 10 times a year because they sell a million of these tiles each year. A million a year. They have the machine running 100,000. This is very common, by the way. Every time they have to reset up that machine, $5,000. It's kind of an outrageous setup cost for this example. I always say that every time because it always catches me. You gotta remember, last time I talked about this was what, January? What are we in, September? So it's surprising me again. Every time I see this. 5,000 setup cost. Holding cost, $10. Every tile we manufacture costs $1 per tile to make. Holding cost, how much? I heard it. 10 cents. 10% of $1. If holding cost was giving you as a percentage, you got to look at what it costs to buy the item or make the item. Multiply. 10% of $1. 10 cents is our C sub H, 0.10. This machine, if it were left on, could make 500,000 per month. Don't forget, demands per year, production capacity has to be per year. You know you got to convert that. Demand, how is demand given to you? We go through a million tiles, we sell 1 million tiles annually, no conversion. If we could make 500,000 tiles a month if we kept that machine running the whole time we're open, conversion. Both the D and the P have to be annual. Same time period. Let's see, the factory's open 365 days a year. There's that. You ready? Wait, I'm going back to the formula. I don't want to look at the answer yet. 2 times D, the annual amount of tiles that go through is 1 million. Or ordering cost, which is now setup cost, is how much? $5,000, I think? Divided by 1 minus D is 1 million a year, right? P, somebody help me, 500,000 times 12 is 6 million maybe? Does that sound right? Anybody did the math on it? 500,000 times per month times 12, 6 million? So what I say demand was 1 million, 6 million production capacity. What's 1 million divided by 6 million? It'd be 1/6, which is 0.16666. What's 1 divided by 6? Anybody calculate? Siri. 0.116? 0.166. 0.166 or 1.6? Point what? No, 0.1666. Okay. All right. So now this 1 million divided by 6 million is 0.17. Minus, subtract it from 1. So it's the opposite. 0.83. Right? Times our holding cost, you told me is how much? 10 cents? 0.1. 0.1 times, what did I say this was? 0.83. 0.83, you got a very small denominator there. Up here, 2 times 1 million times 5,000, giant numerator. Do the math on it, square root it. You ready? Where is it? How many, they're currently running 100,000. They shut down the machine, retool it, make something else, come back later, retool it, make 100,000 more. And they do that 10 times. How many should they be making? No one sees the answer? 346,410. You shouldn't be running that machine only for 100,000. You are wasting so much money. Let me ask you this: why are you only making 100,000? This is how I was trained. This is for years. The person before me was making 100,000. We've always done it this way from the day we own this machine. This is why we do it this way. I want to show you how much money you would save if you would let that machine run and make 346,410 before you shut it down to do something else. And when you come back to run again, you make another 346,000. How many times will you make this one item on that machine in a year? How many times? Instead, right now, you're doing it 10 times a year, 100,000 in a shot. But instead, since you're going through 1 million of them, and now you're going to make 346,410 instead of 100,000, you're only setting that machine up 2.89, about 3 times a year instead of 10 times. Your setup cost is going to come way down. But because you're making so much more, your inventory called holding cost is going to come up. But that's okay. Because the amount you're saving by bringing that setup cost down compared to the amount you got to pay to bring that holding cost up is completely unbalanced. And then you're going to be saving dramatically more than what you have to spend for that holding cost. And so, to show you, I'm going to put 100,000 in to figure out total cost, and then I'm going to put 346,000 in to figure out total cost a year for just that one item you're making, that time. Blah, 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 blah. And your cost for a year right now, you're spending on holding and setup costs, $54,167,000. If you just let it run longer and make 346 instead of 100, you're only going to be spending $28,868. See how much that setup cost coming down, even though you're spending more money on inventory, completely brought the cost down significantly. So they're going to be saving, they almost cut it in half. They almost cut it in half. We're out of time. We'll pick up from right here. This is what I used to do. And I always started with inventory in my presentations at the end of the week because it's almost everybody who's not has a formal inventory system with reorder points and calculating this, every few months, recalculating what the optimal quantity is they should make or order, they're wasting money.
wasting money. You work somewhere. You know, you're not at that point of saying, hey, I'd like to talk about your inventory. But stick your nose in it and say, look, I'm learning this something in class. By the way, this class used to have to do a project in a semester where you had to go, even if it was a part-time job, you don't even have a job, you had to find somebody as inventory and go analyze it for them and then hand in a paper, the report on what you found. Was, you know, just greedy had to be too much. So you get a break.